Hello students, I am Praveen Kumar from AVS Engineering College, Ghaziabad. In this video, we are going to discuss about construction of DC machine. As far as electrical machine operation are concerned, the entire machine operations are majorly divided into types. One is motor operation and other one is generator operation. In motor operation, electrical input is given to the machine and mechanical output is taken, whereas in generator operation, input is converted into electrical output. As far as a DC machine is concerned, there is no basic difference between a motor and generator. Here, this picture shows a axial view of a four-pole DC machine. This machine can act as a motor as well as generator depending upon the type of input given to the machine. First of all, we will discuss the various major constructional part of a DC machine. So in this diagram, we can see that the various parts are of a four-pole DC machine. Here, the outermost covering of machine is known as yoke or frame of the machine. So this yoke or frame of the machine. And from the frame, on the inner periphery of this frame, we can clearly see the field poles. So this is north field pole, this one is south pole, this one is again north and south. These field poles are basically mounted on the inner periphery of the frame of machine with the help of bolts and other arrangements. On the field poles, there is a winding is wrapped. This winding is known as field winding. The purpose of this field winding is to develop the working flux of the machine. Then we can clearly see the extended part of these field poles. This extended part of this field pole, this is known as pole shoe. Later we will discuss the use of this pole shoe. After pole shoe, there is a air gap, and purpose of this air gap is to distinguish or differentiate the stationary and moving part of the machine. The length of this air gap depends upon the rating of the machine, and usually it varies from 0.2 mm to at max 1 mm. After this air gap, there is this inner assembly is known as armature core. This armature core assembly can be divided into of two parts. So one is armature core and one is armature winding and other one is armature core itself. The purpose of this armature core is basically to provide housing in which we can accommodate the armature winding. And on this armature, then we can see another circular segmented structure. This structure is known as commutator. And on the outer surface of the commutator, we can see the brushes. The purpose of these brushes is to collect the current from the armature conductors, depending upon whether this machine is operating in generator mode or motor. And right now, this machine is acting as a generator, and here these brushes are providing the output of the machine. So here we are getting DC output of the machine, and this is the central shaft. Basically, central shaft, all the rotating part of the machines are aligned across this central shaft. Now, we will discuss one by one the different parts of this machine and their main function. So first of all, field poles. The field poles basically they are electromagnets, and purpose of these field poles is to develop the working flux of the machine. Depending upon the availability of current in the field winding, the field pole get energized. Basically, the field winding is done in such a manner that the field pole attains alternate polarity. Here we can see this upper pole is if at north pole, then the winding is done in such a manner the adjacent to this north pole we get a south pole and then again north pole. So the windings are wrapped in such a manner that field poles gains alternate polarity. When current flows in this field winding, the field poles develops the flux of the machine. Then this flux developed in the field poles through with the help of pole shoe, it reaches in the air gap. So this extended portion this extended portion of filled poles is known as pole shoe, or sometimes it is also known as pole face. The purpose of this pole face or pole shoe, basically it serves two purposes. The very first purpose of this pole face is to provide mechanical support to these field windings. As we can see that these field windings are wrapped along the entire length of these field poles, and they are in the inner side of the periphery. So by extending this pole face, this field windings get additional mechanical support. One more thing, by extending these field poles in the form of pole shoes, we can maintain a uniform distribution of flux in the air gap. If these field poles are not extended, then the problem arises that flux will concentrate only along the polar axis. And as we move away from these polar axis, what will happen is the density of the flux starts decreasing. So in order to get uniform flux distribution, this extension of field poles in the form of pole shoe is necessary. The field poles, basically they are made up of laminations, and their construction can be shown in this slide. This is a laminated field poles. Now, the main reason behind using such type of laminated structure is to minimize eddy current. Now, question arises that why the eddy currents are developing. So that we can discuss here. Basically, these field poles are made up of laminations. Although a DC current is flowing in the field winding, it means the flux developed in the field poles is of constant polarity and constant magnitude. Also, the field poles are stationary. But as the flux emerges out from the field poles and reaches in the air gap, because of rotation of the armature assembly, the air gap flux starts vibrating. And due to this vibrating air gap flux, eddy currents are developed in the body of the field poles, and in order to minimize these eddy current losses, the field poles are made up with the help of lamination. So the entire field pole is designed in the form of this type of laminations. And here we can see this extended part pole shoe. And at this pole shoe, where the field windings are placed, so they can get additional support. Now moving to the next part of the machine, that is the armature. This armature, the entire armature can be divided into two parts. One is armature core and other one is armature winding. So here, this armature core is made up of laminations. This armature is not made up of solid piece. Instead of solid piece, we use armature laminations. These laminations are having thickness around 2 to 4 mm depending upon the rating of the machine. And these laminations can be circular, semicircular, or quarter circular. That depends on the rating of the machine. On the outer periphery of these laminations, we have slots. In these slots, we can place armature windings. Here is the central hole across which all the lamination are aligned in order, and they develop a circular, they develop a cylindrical core along which the outer periphery we have slots in, and in these slots we can place armature windings. Across on the each lamination there are some air holes, or these are known as cooling ducts. These cooling ducts basically travels along the entire axial length of the armature core, and the purpose of these cooling ducts or axial holes is to provide a path for the flow of coolant or air depending upon the requirements of the machine. The entire armature core, when prepared across these outer slots, we place armature windings. These armature windings basically are in the form of coils, and in each coil basically two conductors are connected together. Both the start end and finish end of all the armature coils are connected to the commutator. Here we can see that in this diagram there is a armature coil. This is conductor 1 and this is conductor 2, and this is the end connection. And both the start end and finish end of the coil is connected to the commutator segments at one side. This commutator is also a segmented circular structure which is made up of the copper, and the outer surface of this commutator is polished to a very high degree. This surface should be kept as smooth as possible. Reason behind this is on this outer surface of commutator, we have brushes. So these are the brushes usually made of carbon, and these brushes are commonly in contact with the commutator. So when the shaft rotates, when the here, when the shaft rotates, along with the shaft, the entire armature assembly and commutator rotates. But the brushes which are placed on the surface of commutator, they are stationary. And from these stationary brushes, we get connection for the external load, or we can connect the supply depending upon how this machine is operating. So basically, as the brushes are stationary, so during normal working of the machine, there is a continuous friction between the commutator and the brushes assembly. So in order to avoid any damage to the commutator, it is advisable that these brushes should be made up of a soft material like carbon. So in low and medium rating of machine, we prefer carbon brushes. But when the rating of machine is very high, the design of carbon brushes is becomes impractical, and in such cases the only option left is metallic brushes. Although in that scenario, due to metal friction between commutator and brushes, the damage occurs on the brushes surface as well as commutator. So in large rating machine, the maintenance of commutator becomes more important while regular checkups. So this is the construction. Now, one important point is the same machine can act as motor as well as a generator. It depends upon which type of input we are providing to the machine. For example, if we connect this central shaft to a prime mover and provide rotations. So, due to the rotation of armature conductors, they will cut the flux provided by these field poles, and in conductors, EMF is induced, which is collected by the brushes and available in the form of output. So, we can say that mechanical input given to the armature conductors is converted into electrical output at the brushes, and in such case this DC machine is acting as a generator. Similarly, the same machine can act as motor, and in case of motor, the input is DC input is connected at the brushes, and when we connect DC supply at the brushes through the brushes and commutator, this DC supply uh, flows through the armature conductors, and these current carrying conductor interact with the magnetic field produced by these field poles, and due to interaction between electric and magnetic field, a torque is experienced by the armature conductor, and the entire armature assembly starts rotating. In that scenario, we can say that DC machine is acting as a motor, as it is taking electrical input and providing mechanical output. So these are the important constructional part of a DC machine. I hope you enjoyed watching this video. These are the references which are used while making this video. So I hope you enjoyed watching this video. Thank you.